So these are our informal geometry notes for section 2.1 segment bisectors. So this is an activity at the beginning that we may or may not be able to do in class. I know it's a little bit weird, but I can't really do that activity on this video without paper. So we're going to scroll past that and we're going to look at the examples. But maybe we should talk about what a segment bisector is. So let's think about segment. So we know what a segment is. Segment means I've got two endpoints, something like this. Not a very straight line, but you know what I'm trying to draw. And then bisector. So if we think of bicycle, we think of the number 2. And then sector to me almost means like we're cutting something. So we're basically cutting it in half. So if I think about a segment bisector, it means I'm going to divide this exactly in half. And the little segment on the left is going to be the same as the little segment on the right. And so I'm showing that by making 2 of these little marks on each side to show you that they're equal. So we'll do that. We'll mark geometry diagrams that way. So whatever's equal, we'll get those same kind of markings. So let's go ahead and scroll down and look at a couple quick examples. So for this one, it says line L is a segment bisector of AC. And again, like here's one little hash mark on each side, shows you that they're equal. Find AC if AB is 6 centimeters. So let's go ahead and figure it on our diagram. If from A to B is 6 centimeters, and I know that from B to C is the same, they're equal. That's what these little marks here mean. That's what segment bisector means. Then this is also 6 centimeters. So then if I'm wanting to find AC, that means I'm trying to find the entire length. I know I do that by adding. Or I could think about multiplying this by 2, right? I could do 6 plus 6, or I could do 2 times 6. But either way, my answer is going to be 12. So AC is going to equal 12. And remember, we're not putting the segment symbol above AC because we're talking about the distance from AC or the length of the line segment AC. So we do that when we're talking about a distance or a length. We don't put the symbol on top. So the next one, I am told that line L is a segment bisector of RT, of segment RT. So this one kind of goes at an angle, but it doesn't matter. S is still going to be the midpoint. It's still the middle of the line segment. And we have marks here to show us that RS is the same as ST. And we know that RT, that entire thing, is 109 inches. And this time I want to find ST. So I'm looking for this one right here. So when I started out with a small piece and I knew it was a segment bisector and I was trying to find the whole thing, I could double it. So now when I'm trying to find half, I can divide it by 2. So I'm going to do 109 divided by 2, and it doesn't divide evenly, but that should be 54.5 inches. So if you've got, you know what, I didn't write centimeters on this first one. If we've got units, we should use them. So let's go ahead and scroll. Next one is asking us to, it says M is the midpoint of line segment XY. So we can see M is the middle. So what that tells me then is this piece here. We've got that mark that says it's the same as this piece over here. So because they are the same, I'm going to set them equal. So I'm going to go ahead and write that x plus 6 is equal to 3x. So I have a 1x. I'm going to subtract 1x on both sides. When my variables are on both sides, I can't combine them. I have to cancel. I got to do stuff to both sides that's the same. This makes a 0. So 6 is equal to 2x. Then I'm going to divide both sides by 2. And so 3 is equal to x. So now I want to find xm. So xm is labeled as x plus 6. So xm is x plus 6. And I'm going to go back and replace the x with a 3. So we are substituting. And so xm is going to be 9. So next we're working on average. So average is when I want to find the mean. You guys are really good at finding averages when it's things like a test score. So I'm trying to find the middle or the average of these two. So because there's two numbers, I'm going to add them together. And I'm going to divide by 2. So 8 plus 12 would be 20. Divided by 2 is 10. And that makes sense to me because if I think about these numbers on a number line, if 8's over here 9, 10, 11, 12, and 12's over here. 10 is really the number in the middle. That is the average of them. It is exactly 2 units away from 12 and 2 units away from 8. So it is the average, it is the mean. And we kind of say middle, but middle is a word we associate with median. So we want to be really careful with our language. It is the average, it is the mean. So when I'm trying to find a midpoint, it also is the middle though too. I get you, like it's kind of weird. When I'm trying to find the midpoint, I've got this line segment here, and this is kind of weird. So let's see if we can figure out where the middle would be. 1, 2, 3, 4, 5, 6, 7, 8. It's 8 units this way. So I'd want to pick maybe 4 units, right? Because that's 4 and that's 4. And then let's think about how tall it is from one to the other. So like this kind of lines up with that lower point, and this is my upper one. So when I look in my y direction, it's 1, 2, 3, 4, 5 units. So 2.5 would be right in the middle. So my midpoint would be right here. So let's see. I have no idea what that midpoint looks like. Here's my 0, 0 here. This is my origin. The graph is a little bit weird, right? So 1, 2, 3, 4, 5, comma, 1, 2, 3, 4.5. All right. So next I'm going to come up with my midpoint formula. So midpoint formula, when I'm trying to find if I have 2 ordered pairs, let's start out with that. So midpoint formula is what we use when we have 2 ordered pairs. So 2 ordered pairs I always write as x1, y1 and x2, y2. And I'm trying to find the middle or the average of the 2. So what I want to do is I want to take my x's and add them together and divide by 2. So I'm averaging my x's to get my new x. And then I'm going to average my y's together and get my new y. So this is going to give me an x midpoint and a y midpoint. So that's what my answer ends up being. So this is my formula. But when I do this, like that x1 plus x2 divided by 2, all of that gives me my x midpoint. y1 plus y2 divided by 2, all of that gives me my y midpoint. So we're adding our x's together, we're adding our y's together, we're dividing by 2. So we're using that idea up here when we average things together. And graphically it works out where you're trying to find the middle like we did on number 10. Did not mean to make that graph so big. So last we're going to do just a quick example. I did not mean to draw that line, where we go ahead and find a midpoint. So my x's are -8 and 4. So -8 plus 4 divide by 2, comma, and then my y's are 7 and -12. So 7 plus -12 divided by 2. So let's go ahead and simplify. -8 plus 4 is -4. 7 plus -12 is -5. And then let's just go ahead and divide these out. 4 divided by 2 is 2, so -2. 5 divided by 2 is going to be -2.5 or -2.5. So I don't care in this class which way you write that. So that's going to be our midpoint. So -2, -2.5 is the point directly in between these two. So if I connected them with a line, like we did on our example right up above that, I want to call it example 10 because there's a 10 right here, but that's not what it means. So if I think about drawing those 2 midpoints in and connecting with a line and actually like kind of eyeballing the middle, that's exactly how that formula works out. It's just not always practical to graph things. So please work on your 2.1a assignment and make sure to ask if you need help.